welcome to this webinar, the first webinar. We might run a second webinar prior to our workshop on AIrTonomy, which we believe the AIrTonomy team is a unique cyber-physical infrastructure that will enable researchers in the US and around the world to really create, groundbreaking discoveries related to autonomous air vehicles. So I kindly invite you all to join us on September 11th through to 12th to become a lead user of the infrastructure that we're building, because we will also be offering you 6 months free research access or research infrastructure access. So what I'd like to do today is to give you an overview of what AIrTonomy is, in particular highlighting the unique physical infrastructure, which we call the Purdue Unmanned Aerial Proving Ground, which will set you apart when you use it in terms of discoveries. That's what we believe. We develop an infrastructure for autonomous air vehicles, focusing really on safe and trustworthy artificial intelligence and machine learning, with a goal to close the loop from data to safe and trustworthy action in the real world, where you deploy UAVs in really challenging environments. And when I say challenging environments, I relate to missions beyond visual line of sight. I relate to swarm operations, where you have to fly drones or larger UAV vehicles, fixed wing, for example, across rural areas to get really highly accurate information about, for example, your trees, if you're dealing with digital forestry. But it also, if you're interested in studying signal degradation in urban canyons. What you see on the left-hand side is our big vision, which is the ability to equip, ability for you, or our vision to equip every researcher and engineer around the world to access our facilities from anywhere in the world to then perform their own experiments, having access to ground truth data, high fidelity models, and tools for experimentation. Here's a use case that kind of articulates why we need AIrTonomy and why we need Purdue Unmanned Aerial Vehicle Proving Ground, or we call it the PUP. That's easier to remember. Otherwise, I'm making many mistakes in saying it. Here's a first responder use case, and you see there's a drone, dispatched by a remote operator. The remote operator had set the mission in the remote operating software. It uses computer vision to detect citizens that are injured on the ground. However, the decision to drop or not to drop is still with the human operator. However, when the drone actually detects that vehicle on the ground, that citizen on the ground, he's distracted, so he does not make the decision in time. So the drone will go into a holding loop in the pattern, and eventually, as you can see that on the screen or picture number 3, it hits the building because there was signal degradation, and the planning, the control algorithm didn't consider that. This kind of simple use case articulates there at least two challenges, at least. On the one hand, studying AI-enabled UAVs in urban canyons, where you have GPS-degraded environments, or more broadly, GPS-denied environments, and also the issue of bringing the human into the loop or on the loop if needed. We know that as we increase autonomy, there will be a rare condition where you have to actually involve the human, but if so, bring them in quickly and safely is a key issue of concern. AIrTonomy will bring together different components, physical components, and I'll explain them just in a little bit more, and virtual components or cyber components, such as a digital twin that would represent, for example, a particular vehicle in a real way, because we would use real data collected in real environments, outdoors environments, to represent it, also with the goal to update it in real time. Without going into the overall components now one by one, I just want to introduce you to what we think is really unique about AIrTonomy, the physical infrastructure or the environments, which we call the PUP, the Purdue Unmanned Aerial Proving Ground. It brings together unique facilities that you see on this triangle, which has about a size of, a diameter of 15 miles. That on the one hand are very closely related to Purdue Airport, which is, you might know, the second busiest airport in the US. One is the PERT, another abbreviation. It's the largest indoor motion capture lab that is equipped with a motion capture system that allows you to capture the ground truth, the vehicle position at a millimeter level because of the way it synchronizes onboard LED markers with the motion capture system mounted at the top of the ceiling. At Purdue Airport, we'll also have a SOC, and that's what we will be opening in September, the Smart Operations Center that we believe is the most connected and most immersive operations center, a tactical command center that will define the next generation of remote operation, but also urban airspace management and other kind of tasks you will do remotely, such, for example, firefighting, where you have to monitor fires and make decisions very quickly as a team or individually. And then on the right-hand side of the corner, at Romney, not far away, about 20 minutes drive from Purdue Airport, we will have the Pop Airfield. It's an UAV airport that will also be listed on the FAA map. We're just in the process of building that, where you can run operations with larger vehicles, such as the Ultra that you see here on that screen, which is a large mid-range fixed-wing UAV that can fly more than 600 miles, has a payload of more than 200 pounds, that will cover areas that you cannot cover with other UAVs that you might be using right now for your research. That then connects to what we call the Purdue Urban Canyon Lab that will be established in our wildlife area, where our collaborators who are also in the call and our team members will already performing quite a lot of research using drones related to digital forestry. That Urban Canyon Lab will be equipped with buildings. We're thinking of firefighting buildings, urban structures where we can emulate urban canyons and also study issues on signal degradation. Just like PERT, it will also be equipped with a motion capture system that would allow us then to capture ground truth data or collect ground truth data, and would give you the ability to have access to this data in real time, because of the way we equip also the infrastructure with 5G networks and the cyber infrastructure for then real-time streaming. All this will together really give you the opportunity, for example, to perform or study missions that are complex, where you dispatch a large drone at the Pop Airfield, maybe equipped with smaller drones, and then fly it into the canyon, where they then work on issues like building inspection or first responder use cases that I've shown earlier. Within that area, we'll then establish what we call the Purdue XDM system, the next generation of communication network infrastructure for urban airspace integration. We'll place there an active radar, R1410, together with our partner Saab, and a passive radar at the outskirt of this triangle to ensure that we can detect smaller UAVs that fly at lower altitude also safely. In addition to that, there will be low weather network station at the different locations so that you also get more accurate weather information. I hope I didn't forget anything, but together that really, we think the POP will be unique and will offer researchers around the world to perform research they haven't done before. Here, maybe just a few more details of each of these facilities. On the one hand, the PERT, as I mentioned, is the largest one. It is 20,000 square foot big and has a ceiling of 30 feet. And has that motion capture system. We use Qualisys here at this point of time, and we're potentially considering Qualisys as another vendor for the outdoor motion capture lab. We're also looking into other alternatives. Because of the way we connected with the cyber component, it allows mixed reality settings and augmented reality settings, so that you can also perform research with emulated condition and actually seeing in real time what this emulation looks like. Think about GNS signal degradation or other forms of degradation that you could emulate. Then here's more details on the SOC, the Smart Operations Center. It gives you kind of an idea what we're planning to build there. First responder mission, again, multiple people working on such a mission when they have to, for example, deal with a fire in an urban area, but also a fire in a wildlife area, where they have to make decisions jointly, looking at a big screen or a gridded wall, at the same time having the ability to equip those operators, remote operators, with devices such as a EEG, with pupil labs eye trackers, a wristband for measuring heart rate, or any skin metrics you want to collect, and then use that, for example, for sensing a human operator state in real time, or for designing next generation brain-computer interfaces where you can use your thoughts and to operate a drone by thinking of going right. Or voice-based interaction is also something you might want to consider, for example, to change the way you design missions and plan paths. Then here again, an overview on the Urban Canyon Lab. We believe that this will be the largest urban canyon labs to study signal degradation, with a size of about 12 acres. And the fact that it will be equipped with motion capture system will give you the ability to have access to ground truth data. And again, potential for mixed reality setting. While this doesn't have trees, I would like to highlight that this is closely located with the wildlife area in our digital forestry lab at this point. And so then we actually have in our real world installation and also trees there, and also the ability for you to maybe study rural areas and forestry in urban areas. We do not consider this as being a highly populated area, but rather a rural urban area where there's actually quite low population density, which is very common actually in the state of Indiana, but also other areas in the United States, where urban air mobility plays an important role. Here again, more details of the PUP airfield, some details about our vehicles that we already have and that we can provide researchers access to. Here, the fixed wing vehicle that we currently have for research purposes, and then also have an ops team to run it for you. Size, as I mentioned, 30 feet wingspan, a range of more than 600 miles, payload of more than 200 pounds, and also it flies at a higher altitude that you would typically operate other drones with. And it has a customizable sensor stack, so you could equip it with more than the sensors that you might currently have available. And we would also, would like to discuss what sensors you would like to have as we're building that infrastructure, to maybe have some of that already by default installed. There will be hangars next to that runway, and there will also be an office for our ops team to actually then spend time and interact also with you as you're using that remotely. Here's a kind of a signal how you could a use case scenario, how you could use our infrastructure. Imagine you work on path planning in degraded environments, and you already have access to some of the data that we collected in our facilities. I forgot to mention, we actually plan to run 100 flights a day, indoor and outdoor. There might be really short flights, but the goal is to really collect the data, to have the data that is needed to actually train and validate machine learning models, and also next generation deep learning models. And you have that algorithm validated using us a digital twin. And now the next thing is you want to actually validate outdoors. So we offer you the ability to deploy it on board on our vehicles. At the same time, we would also stream then, when flying outdoors, signal degradation through our mixed reality settings, so that you could emulate that and see how would your path planning algorithm actually perform if you have signal degradation, for example, GNS. But there are also other degradation that you might want to maybe consider. At the same time, there would be an ops team using the SOC and operating. We'll have an ops team ready for that. And another researcher interested in human in the loop could use that data maybe in the future to study ways of interaction. Let's think about speech-based interaction or brain-computer interfaces, many other ways. Forgot to mention the SOC is actually also equipped with a video motion capture system to also capture video data, voice data, and also body movements, facial expression, etc. Yeah, so this is one of the research use cases we could consider. There are more, you can think of. For example, I know people working on digital forestry, precision agriculture are really interested in sensing and perception at multiple scales, getting different wavelengths, etc. flying maybe very dynamically around certain areas because you need to sample in a very targeted way using active sampling. Those are all questions we would like to address. And that's why we invite you also to participate in our call for participation and submit your research use cases. Before I get to that and emphasize that again, we will have a subscription model already drafted for discussion also during the workshop. There'll be a trial version. There will be an hourly rate usage, but there will also be an annual usage where you could use then our facilities. You can schedule experiments either just on one facility like the PERT, but you can also use the whole PUP. And you have our, access to certain quotas in terms of data storage and GPU, etc. This was PUP. And also the cyber component that are core for autonomy. PUP is the proving ground, the ground for proving, for measuring. Now, we would like to take that to the next level, moving from PUP to the smart crossways of Indiana. And that's what you see here on the right-hand side, where we have the proving ground then connected to other facilities in the States, such as Muscatatuck, which is the largest training facilities of the Navy, where we could then extend and fly even further. For sure, we have to work on that. We have to work on regulation. We have to work on the infrastructures, radars, passive, active radars, communication networks, infrastructures. But that's the vision. And beyond that, we are thinking of also then building a corridor that leads to Indianapolis directly. That's highlighted here in purple, small little icons, where we then would move things along the railway and move from research and proving to actual real-world operation. So that's the big vision we have in mind. We would like you to be part of that, and that's why we would like you to invite you to attend the event, the Autonomy Workshop, and maybe also the Smart Crossways launch event, where we will actually opening and unveiling our Smart Operations Center that we actually have ready by then, and also perform then our first remote flight using the Ultra, the large fixed wing vehicle, and with dinners and keynote speeches from people that are also thinking with us on the smart crossways of America. And my last kind of call to action is call for participation. We need research use cases. We want to know what you want to study with autonomy. We'd like to know what the question is, what problem areas you'd like to solve on complex missions and operations, whether you're interested in GPS denied environments, or other kind of issues of degradations, whether you're interested in urban airspace integration, human in the loop, and if so, how you would like to use our components, the PERT, the SOC, the PUP airfield, the PUC, and then also maybe what requirements you have with respect to the digital twin, and also data access and training validation environments for AI, machine learning, and deep learning in particular, as we know that is computationally quite expensive. We have on our website already a call for participation, a website where you can see and what we kind of ask you to submit, but basically, we don't want to put the hurdle too high. A short abstract would be sufficient, and then answering some questions for us so that we can prepare. And we will then actually also award travel awards for the best use cases. You have the ability to participate in poster sessions, lightning talks, and also breakout sessions to showcase your ideas and how you could use autonomy and the PUP. So that's it from my point of view at this point. Here's also a link to our RSVP.